Let's be honest. Traveling to Mars isn't going to be easy. There's a reason why humanity has never set foot on the red planet, while only a handful of highly advanced and incredibly expensive robotic landers have. A journey to and from Mars presents a multitude of challenges, each more complex and dangerous than the last. The trip is long, perilous, and far more difficult than any space mission humans have ever embarked upon. While the idea of exploring Mars has sparked imaginations for decades, there are still significant hurdles that make it an extremely daunting task. The deep reaches of space are filled with challenges that stretch the limits of our current technology and human endurance. So, why haven't we been to Mars yet? And why is it so difficult? Let's break it down. The length of the journey. For one, humans simply aren't accustomed to being in space for such extended periods. A round-trip mission to Mars would take an astonishing 21 months. That's nearly 2 years, 9 months to reach the planet, 3 months spent on its surface conducting research and exploration, and another 9 months to return home. The sheer length of the mission would pose unprecedented challenges for astronauts. Spending almost 2 years in space would require an extraordinary amount of physical, mental, and emotional resilience. Every single second spent traveling to Mars can be easily translated into energy, fuel, and of course, money. The costs are astronomical, no pun intended. It would cost thousands of dollars per second just to sustain the spacecraft, the astronauts, and all the systems necessary to keep the mission alive. Beyond the financial strain, there's the equally critical issue of human health. Prolonged exposure to the harsh conditions of space, including microgravity, radiation, and isolation, can have severe impacts on the human body. Muscles weaken, bones lose density, and the immune system becomes compromised. Even with all the advanced space medicine we've developed, keeping astronauts healthy during such a long mission would be a monumental task. This is one of the major reasons many experts are hesitant about sending humans on a Mars mission right now. But what if there were a faster way to get there? What if a trip to Mars didn't have to take nearly 2 years? The case for faster space travel. A growing number of scientists believe that it's possible to dramatically shorten the time it takes to get to Mars. Instead of spending 21 months traveling to and from the red planet, why not reduce that to just a fraction of the time? What if we could get to Mars in just 3 days? This revolutionary idea is more than just a pipe dream. It could become reality if emerging space travel technologies continue to evolve as expected. These new methods of space travel wouldn't just reduce time and cost. They would make interplanetary voyages far safer and more efficient. If we could significantly cut down the travel time to Mars, it would open up unimaginable possibilities for space exploration, colonization, and even tourism. We would enter a new golden age of space travel, one where humans could venture to Mars and beyond. The legacy of chemical rockets. Since the dawn of the space age, chemical rockets have been the most commonly used method of propulsion. The iconic Saturn V rocket that powered the Apollo missions, and more recently, SpaceX's Starship, are based on chemical propulsion. In many ways, SpaceX's rockets bear a striking resemblance to those early rockets that Americans took pride in during the height of NASA's space program in the 1960s. The basic principles behind chemical propulsion haven't changed much in the past 60 years. Chemical fuel is burned to create thrust, allowing the rocket to escape Earth's gravity and propel itself into space. However, SpaceX's modern technology far surpasses anything NASA could have dreamed of during the Apollo era. Elon Musk and his team at SpaceX have revolutionized the space industry by developing rockets that not only push the limits of performance, but also dramatically reduce costs. The Starship is poised to be a game-changer for space exploration, and much of this potential rests on the Raptor Engines, the cutting-edge propulsion system that will power both the Starship spacecraft and the Super Heavy rocket booster. The power of SpaceX's Raptor Engines. The Raptor engines represent a quantum leap in rocket propulsion. These engines are known for the staggering amount of power they generate, but their most revolutionary feature is reusability. Reusability has long been the holy grail of space travel, as traditionally, rockets are used once and then discarded, making every launch prohibitively expensive. By developing rockets that can be reused multiple times, SpaceX is drastically lowering the cost of space exploration, making it more accessible than ever. While the Raptor engines burn chemical fuel just like their predecessors, they do so in a much more efficient and powerful way. Most rockets rely on liquid oxygen and kerosene to produce thrust, but the Raptor engine uses liquid methane combined with liquid oxygen, a combination rarely seen in the space industry. This unique fuel mixture allows the Raptor engines to produce unprecedented amounts of energy. The engines are also built to be more efficient, converting more fuel into usable thrust. The upcoming Raptor 2, currently in development, promises to push these capabilities even further. Despite the Raptor engine's incredible power, there's still a significant problem. Even with this next-gen technology, a trip to Mars would still take about 9 months each way. This leads scientists to explore other methods of propulsion, ones that could potentially get us to Mars in much less time. The promise of nuclear-powered rockets. Enter the era of nuclear-powered rockets. These rockets could transform space travel as we know it, potentially cutting the travel time to Mars by more than half. Instead of burning chemical fuels, a nuclear rocket would rely on a nuclear reactor to generate heat. The heat from this reactor would then be used to superheat a propellant, typically liquid hydrogen. The resulting gas would expand and be ejected from the back of the rocket, generating thrust. This method is much more efficient than traditional chemical propulsion and could produce twice the thrust per unit of propellant. With a nuclear-powered rocket, a trip to Mars could take as little as 90 days. That's 3 months, compared to the 9 months it currently takes using chemical rockets. Such a reduction in travel time would not only make Mars missions more feasible, but would also significantly reduce the risks to astronauts' health by shortening their exposure to the dangers of deep space. Of course, the idea of using nuclear power in space isn't without controversy. Many people are understandably concerned about the potential dangers of launching nuclear material into space. The memory of disasters like Chernobyl and Fukushima looms large, and the idea of nuclear accidents in space raises a lot of red flags. However, nuclear-powered rockets are designed with numerous safeguards in place to prevent any radiation leaks or exposure. For an extra layer of safety, the nuclear reactor wouldn't be activated until the rocket has safely exited Earth's atmosphere. The spacecraft would rely on conventional chemical rockets to get off the ground and into space, only switching to nuclear power once it's well beyond Earth. Despite the concerns, nuclear-powered rockets could be the key to unlocking faster travel to Mars and other distant destinations in our solar system. The potential of ion engines. If nuclear power doesn't sit well with you, another promising option is ion propulsion. Ion engines are a type of electric propulsion that could significantly speed up travel to Mars. Instead of burning fuel, an ion engine works by accelerating electrically charged atoms, known as ions, through an electric field. These ions are expelled from the back of the spacecraft, creating thrust. The beauty of ion propulsion lies in its ability to continuously push the spacecraft forward once it's in space. While traditional rockets produce a powerful burst of thrust during launch, ion engines provide a steady, continuous push. This has been compared to the wind pushing a sailboat. Once the spacecraft has exited Earth's atmosphere, the ion engine would gradually accelerate, reaching astonishing speeds. In fact, spacecraft powered by ion engines can theoretically reach speeds of up to 200,000 miles per hour. This incredible speed would cut down the travel time to Mars to just 39 days. While ion engines have a slower initial acceleration, their continuous thrust over time allows them to achieve much higher velocities than chemical rockets. This makes ion propulsion ideal for long-distance travel within our solar system. The future of photonic propulsion. But what if you need to get to Mars even faster? Enter photonic propulsion, the most futuristic and potentially transformative method of space travel. Photonic propulsion relies on the momentum of light particles, or photons, to propel a spacecraft. While photons have no mass, they do carry energy and momentum. When they reflect off an object, they transfer some of that momentum, causing the object to move. The concept of using light to power a spacecraft might sound like something out of science fiction, but it's been in development by scientists for years. If we can fully develop and harness the power of photonic propulsion, it could enable spacecraft to reach incredible speeds. A small robotic craft powered by photonic propulsion could potentially make the journey to Mars in just 3 days. Imagine that. Instead of spending months in space, you could arrive on the surface of Mars in under a week. While photonic propulsion is still in the early stages of development, the potential is mind-blowing. If successful, this technology could revolutionize space travel as we know it, making the vast distances between planets feel much smaller. It could open the door to deep space exploration, allowing us to reach planets, moons, and even distant star systems in a fraction of the time. A new era of space travel. All these emerging technologies, nuclear propulsion, ion engines, and photonic propulsion, could radically change how we travel through space. If we can significantly reduce the time it takes to reach Mars and other planets, the possibilities for exploration and even colonization become much more realistic. Imagine a world where interplanetary travel is as common as hopping on a plane for an international flight. In the not-too-distant future, we may be able to visit Mars, establish colonies, and continue to push the boundaries of human exploration. The race to develop these technologies is well underway, and the next decade could see some truly groundbreaking advancements in space travel. If all goes as planned, we may witness a new golden age of exploration, one where humans venture beyond Earth and take their first steps on distant worlds. What do you think of these revolutionary methods of space travel? Are you excited about the future of interplanetary exploration? Let me know your thoughts in the comments below, and don't forget to like and subscribe for more exciting space-related content.